Today, we're excited to be able to show you our new runtime. V2 Runtime is a major update that reflects our way of thinking about integration, informed by over 10 years of experience. I'm Daniel Chilcott, co-founder at Flowgear, and I'm joined by software engineers Cassandra Wallace and Ricard Skostro. Our objective for V2 Runtime was to modernize the design experience by providing a beautiful information-dense user interface that enables experts to move with precision and speed, their work augmented by agentic AI when it's wanted. And while AI accelerates experts, it's also the perfect way to help new users immerse. So we've made it easy to build a functional workflow with a one-shot prompt. Let's start by having a look at the new designer.
All right, thanks, Dan. So we're just going to start off here by navigating to our workflows list. So you can find this on the left-hand side of the menu. So in here, we're just going to click on this drop-down, select the new V2 Runtime workflow. So just going to open this up. So what you can see is our new designer. At the top, we have a list of actions. You can choose your environment, save the workflow. Just going to create a name here. So for this purpose of this demo, we're just going to do a Salesforce to Intacct contact sync. So just going to give it a name, give it a save. Okay, now what we have here, we have the parameters and the returns in the workflow. So the parameters are the input and the returns is the outputs. The bottom here, you have a view switcher. So we have a code view and a canvas view. We'll touch on this in a bit later. And then down here at the bottom, we have a logs pane as well as a diagnostics pane. We'll also touch on this in a bit. So first we'll start by adding a step. So this is our step configurator. So I'm just going to select Salesforce. So in here we have a list of methods. So we want to query Salesforce contacts. So I'm going to query this and then going to select our Salesforce connection. So this is the connection or the credentials for the specific Salesforce instance. Then we're going to have a list of templates. So the templates define the list of properties for the specific step and specific method. So it's just going to go ahead and select that. Okay, now we have our first step on Canvas. So what you see here at the top is our parameters section. So this is the inputs for the specific step. We have the connection that we just selected, as well as a query. So this query I'm going to leave as is, as this is basically just selecting a list of fields from our contact object. Just going to close that down. And down here at the bottom, we have our returns. So this is what's going to be returned from this specific step. In this case, we're going to have our list of items, and each with specific properties. What we can also do is check here on our edit properties. So you can add and remove items from the schema as needed, but we're going to just leave it at our default template. So now we're going to add the Sage Intacct step. So again, we're just going to open our step configurator, select Sage Intacct REST. This time we're going to select the mutation method, as we want to actually go ahead and create a contact. So we're going to select the Sage Intacct connection. Again, we're just going to search for contacts. We want to create one this time. Just going to go ahead and select that. Now we'll have another step on our canvas. This indicates the request needed to actually go and create a contact in Sage Intacct. So we're just going to start by creating mappings. One thing to note, if you are familiar with V1, is that now the execution flow is implicit by the order of the steps on the canvas. No need to longer drag the connection order. So just going to go ahead and connect items. So this is for each contact, we're going to go ahead and create a contact. In ID, there's something I want to touch on. So we have a list of functions, very similar to Excel. So we have a different range of functions. We have mathematical functions, we have string functions, we have date and time functions, other miscellaneous functions, quite a few of them. So for this, I'm just going to use our GUID function, which is going to generate a unique ID so that we can create that in Sage Intacct. In here, we also have some autocomplete functionality to select specific properties that has been connected to the step. So now I'm going to go ahead and connect last name to last name. Going to have my first name go to first name. Just going to map one or two other properties down here. Just going to get phone and email. So we have phone to phone. Then we'll take our email. And then lastly, I'm also going to just use a print as. So for this, we also want to use a different type of function. So I'm going to take my last name here, as well as my first name. Because what we're going to do now is actually concatenate this into a single string. So I'm just going to remove this. Okay, now I'm going to type concat. As you can see, there's a list of functions that appears autocomplete. Okay, then I'm going to take my first name. I'll add a space in between, and then I'll add the last name. Okay, once we have that sorted, just go and connect, and then we're going to run this workflow. So now what this is going to do is go and get the data from Salesforce, query the rows, and then create the contacts in Sage Intacct, all in real time. There we go. All right, so now we've seen the visual designer. Now for those who like working with code, there's always a code view underneath. So we built a declarative spec for workflows that's actually pretty readable. It's basically like structured text. And the cool thing is you can flip between the visual view and the code view anytime you want. So while we have this on canvas, I'm just going to go ahead and switch to our code view. So what this is like a IDE experience. So we've worked hard to give you like professional features like syntax highlighting, code folding, autocomplete, as well as linting. You can also add a step like we saw now in the canvas, specific in the code editor. The real thing I want to touch on here is our diagnostics pane. So we have real-time diagnostics, so you don't need to go and save or run the workflow. You literally make changes to the workflow and it should compile and give you a list of errors as we go. So here we have our problems pane open now. So just going to resize this. As you can see here, we have a helpful error message stating that implicit keys can't be on a single line. This is now because we broke this YAML. It also gives you a specific code as well as a line number where this occurred. So what's powerful of this is that it's real time. So no need to go and save. So I'm just going to undo, get the changes fixed, and we should see those problems disappear. Now, moving back again to the canvas view, we also have this feature available here. So it doesn't matter which view you work on. Both are just as powerful. So in this view, I'm just going to go ahead and remove this mapping. The reason why this would break is because children of this container has a mapping, which means that the parent also needs to have a mapping for this. So what we can see here is properties with child expressions must declare expression has popped up. So we have the missing contain expression code as well as a path to where this actually occurred. So now I can just go ahead and hook that back up, and we can see again the problems disappear, and we are once again ready to run this workflow. All right, so now we've seen the designer. Let's talk about what's happening under the hood, the engine itself. So here's the thing, it's pretty straightforward to build a workflow that syncs 100 records. But when you need to scale up to 1,000 or million, that's where it gets tricky. You run into memory issues, so traditionally you have to add all this extra logic, splitting data into chunks, looping through batches, and all of that stuff. So we made a key decision, lazy evaluation for every connector. What this means is that connectors only pull in data they actually need when they need it, instead of trying to load everything up front. The payoff? A simple workflow you build for 100 records works exactly the same for a million records. No need to redesign, and the same thing for large files. Process any size without needing to change your workflow. So just going to pass this over here.
Thanks, Rick. We're going to show this in a real workflow. Let me get that open here. All right, so this workflow here fetches invoices from our Microsoft SQL connection, and then it converts that into a JSON document, which is then saved as a JSON file. The first step, query invoices, returns an enumeration of 10 invoice records as this items output array. That enumeration is then fed directly into the second step, build JSON via an expression, as you can see here. So the engine is simply iterating. For each invoice row, it serializes it into JSON and then appends it into the JSON document that is being built. Let's give this a run here. Now, because this is done lazily, we don't have to wait for all 10 rows to be retrieved before anything can actually start. As soon as the first few rows are available, build JSON can start producing JSON, and save file can actually start writing bytes to disk as it receives it. And as we just saw in the run here, this is that step execution overlap that we saw with the Microsoft SQL step and the JSON document step. They were able to execute at the same time, instead of strictly executing one step running at a time. So that is lazy evaluation in action. Items are processed as they are pulled and not materialized up front. That's why this exact same workflow will work for one row as it does for 100,000 rows. There's no extra chunking or looping steps necessary. So as we go on to our next section, with workflows scaling to process large volumes of data, we needed to rethink logging. Workflow logs now show previews of input and output payloads, and they also show the amount of data being processed while the workflow is running. So we're going to stay on this exact same workflow here, but I'm going to change the query from 10 invoice records to, let's say, 400,000. Let's commit that change and give it a run. As it runs, please look at the logs here at the bottom. You can see these live progress counters, and it shows the row count and the bytes being processed ticking up in real time. For a big job, you can now immediately know that it is moving, roughly how far it has progressed, and just where in the process it currently is, all without having to wait for the final result. Secondly, you may have noticed here that we have these payload previews that you can actually inspect during processing. These are these bin files. So even though that we're processing thousands of rows, you can actually still get a compact preview of what is flowing from step to step. And this gives you enough to validate data shape without having to expand massive payloads. Large volume runs are just not a black box anymore. You can see both the data shape and the throughput as it happens. So altogether, just to tie off our lazy evaluation and logging sections, in V2, lazy evaluation keeps your pipelines moving efficiently, while our new enhanced logging keeps you informed in real time as it runs. I'll pass it on to you, Daniel.
So aside from scaling to process large volumes of data, we built the runtime to add as little overhead as possible. And we do this by generating code from the workflow definition and then compiling that code to binaries. Because the workflow is pre-compiled rather than interpreted at runtime, it's able to execute as fast as a hand-coded app. So we see Flowgear as a new kind of IDE, an integration development environment. And in a future version, you'll also be able to take those compiled assets and ship them as part of your own app or service, enabling integrations that can run independently of Flowgear.
Now, if you're a developer, you're probably enjoying how agentic coding feels like a force multiplier. You're able to focus on high-level design while AI runs implementation for you. We've worked to craft that very same experience for you with our new designer. Our new V2 Help Assistant is not just a troubleshooter, but an agent that can build and run workflows for you. It acts on your behalf for the work that you delegated while you stay in control. We've equipped the agent with a set of tools that enable it to not only compose workflows, but also test and evaluate results. This means that the assistant is able to identify and correct errors over multiple iterations. The result is a high-quality design, where the trial and error work has all been done for you. Now, because the assistant does take some time to talk to other systems, I'm going to first kick off all of our demos for today up until their final interactive moment, and then I'll continue with some main points while our assistant keeps on working for us in the background. This actually highlights one of the core capabilities of our assistant, how it front-loads user decisions so that you can set it, go make a cup of coffee, let it run, and come back to it later. Let's take a look. So I'm just going to fire off our three demos for today. Got that in. All right, perfect. So we're going to start with a workflow that is currently failing so that we can show how debugging works with our new assistant. Now we're going to continue with the same Salesforce to Sage Intacct contact syncing that we've carried through with today. As you can see here, we have a little Sage Intacct error payload, and it is a little unintuitive. You often get a very generic top-level message, such as this payload contains errors, and the real clue can be quite buried deeper in the error response. So in this scenario, even after digging through this error response and also taking a look at the docs, I still haven't been able to pinpoint what's wrong with my workflow. So what I've done is I've actually handed it off to the assistant, and we're going to see if it can pinpoint the issue for us and propose a fix. It's also just confirming which connection it should use to do various template discovery for us. I'll touch on that just now. Just going to select that. One key point is that the assistant has a tool to view the current workflow that you've seen. So it can keep up with the changes that you make to your workflow in real time. Now that that's ready, let's go on to our next demos for today. For the next two demos, we really wanted to showcase the assistant's one-shot workflow generation. For this one, I wanted to create a workflow that takes my ConnectWise service tickets and saves them into my Microsoft OneDrive. So as you can see, as soon as I prompted it, it immediately got to work. It behaves like an agent and starts by discovering what's available, the connectors and their various methods and templates. This uses the exact same building blocks that you as a user has access to in the canvas. Now you will see, as before, that it paused for important human decisions such as selecting a connection. This is important because it's a security design that we implemented in our assistant to not have blanket access to every connection on your tenant, and it must explicitly ask you as the user to choose which ones it should use for a certain build. So here it's confirming which connection it should query the service tickets from, specifically for ConnectWise. I'm going to give that a selection. So now it is able to use that connection for various future tool calls, such as we've just seen here. It pulled all of the available templates for the query method on our ConnectWise connector using this connection that we've just selected. Then it's going to continue doing some more node discovery, for example, the file connector and the JSON document connector, because that's what it's going to use to shape those service tickets that's going to be uploaded to our Microsoft OneDrive. And as you can see here, it's done the same to prompt me for which Microsoft OneDrive connection to use to do the upload. Let's give that a selection. So at this point, this assistant has all of the connections it needs to finish this build for us. So we're going to let it run and jump on to the next. So for the second one-shot example, I wanted to create a workflow that fetches my staff items from a Microsoft SQL table and then writes them to a zip file. You can see the same pattern here where it immediately started to work and initiated that node discovery process before also pausing to confirm which SQL connection it should use to fetch the staff rows. So I'm going to choose the SQL connection that I know has the staff table. Perfect. So now it has the connection it needs for this build, and it can continue working for us. So currently, the assistant is running in parallel across our demos for today, working in the background for us. Let's jump to some deeper points about the new assistant, and we can come back to its results at the end. Our V2 Help Assistance language is powered by OpenAI's ChatGPT. We pair that with Flowgear's explicit tool calls so that the model can plan, test, and then act in a controlled way. That's the balance that we wanted, high capability within the guardrails that we've defined for it. It goes beyond troubleshooting. Now you can ask it to build this workflow, fix that mapping, or run and show me the output. It is an assistant that can act and not just advise. When it hits an error, it doesn't simply stop at a suggestion and leaves you to do the rest. It keeps on going, continuing that detect, diagnose, repair, and then verify loop. This allows you to get from failure to fix in one conversation. Under the hood, we expose an explicit set of in-house tools that lets the assistant perform the same actions that you can take in Flowgear, such as fetching connector context, making changes and debugging workflows, and of course, running workflows to validate results. In practice, it is the same product actions you take, but faster and with fewer clicks from you. And because many of these calls are independent, it can work in parallel, such as fetching templates for multiple nodes at the same time. The benefit of this is simple, less of that serial back and forth for faster results. Perfect, so now we're going to jump back to our demos and we're going to see how our assistant did for today. First of all, we're going to start with our debugging workflow. This is the fix for how we're going to fix the error that we were struggling with for our Sage and Tax step. And it's finished with a proposal. Let's take a look at what it built for us. Perfect. So as you can see here, it actually correctly mapped the ID for the stage and tag step. If you had a keen eye before, you would have noticed that that was the purposeful error that we were struggling with. Let's give this a run and we'll quickly look at the little summary that the assistant gives to explain the approach it took, but particularly for this case, how it found the fix and what it did to actually solve it. And also the result of the test run, as well as just a little bit more information that the assistant can offer about the error we were experiencing. Let's take a look at that run. Perfect. So it looks like it's now successful. And we can see here that we have the 3 successfully created Salesforce contacts in Sage Intacct. So that's great. That really shows the power of using our assistant for debugging errors and how it was able to get us from failure to fix for this example. Perfect. Let's go on to the next. So this was the ConnectWise service tickets uploading into Microsoft OneDrive. After the final select connection here, it continued working, it looked at some templates and did some test workflow runs before finally proposing a workflow for us. Let's take a look. All right, perfect. This is looking correct. It's correctly queried the top 25 tickets from my ConnectWise connection using our ConnectWise connector. And that is then fed into the JSON document step, which is then streamed into our write file procedure, which is then finally streamed to the upload into Microsoft OneDrive. On to the third example here. This is the Microsoft SQL fetching from my staff table and then writing them to a zip file. After the selection of my SQL connection, it did some continued node discovery as well, looking at some templates, getting some more context about how to build this workflow for us before doing a test run and then proposing a workflow. Let's take a look. All right, this is looking good. It's used our Microsoft SQL connector. It's queried the top 25 from my staff table, and that's then fed into our flat file document to create the text file. It's correctly streamed here into our zip connector. Perfect. Let's give this a little run here while we look at the assistant summary. As before, just a quick summary about the approach it took and also the result of its test run, just so you can know how it approached the problem that you gave it. Let's take a look here. Perfect. Looks like it's a successful workflow. It's properly queried our staff items from our SQL connection. And then that's been fed into the text file that's ultimately been saved as a zip. All looks great. So that really shows us the power of both using the assistant for debugging purposes, but also its one-shot workflow generation. So that's it for the new Help Assistant showcase. On behalf of the team here at Flowgear, we are very excited to get this into your hands and to see what you can build with it. I'll pass it on to you, Daniel.
All right. So we've reworked triggers to make sure they're always part of the workflow design. So HTTP and MCP tool invokes are now expressed as nodes rather than managed separately. For these invoke types, the workflow will start with a receive step to accept the HTTP or MCP request, and then end with a corresponding respond step to send the result back to the caller. We've also tightened up scheduling with a new scheduler node that also supports cron expressions for more complex time-based triggering. And we've heard your feedback about how we measure active workflows on scheduled workflows. So now workflows that fire from a scheduler will only be considered active when the steps after the scheduler are running. Let's have a look at how some of these trigger nodes look inside a workflow. So we'll begin with the schedule node. Here you can see an example of the daily schedule. We have a weekly and a monthly variant on this as well, and then a separate connector to deal with if you want to use a cron expression. In this case, we've got the start and end times, the interval that we want to use, as well as the period for the interval, either minutes or hours, for example. And then we've also added an option to control the number of instances of this workflow that are allowed to run. If you set this to true, single instance, it'll guarantee that only one instance of this workflow is running. That's important if you have something like a month-end process where you need to be sure it doesn't run more than once. Also, although those are the input properties, you'll see that we've got outputs or returns here where you'll be able to use values that are emitted, such as the time that it actually ran. So if you need to store that in a log, for example, you've got an easy way to access that without having a separate step. Let's have a look at the HTTP connector. So again, the HTTP and MCP steps have two complementary connectors each. So here we've got HTTP receive, and then at the end of the workflow we'll have respond. So let's look at receive quickly. Here we have two input parameters, one to specify the method that we want to watch on, and then the template that we're going to associate with this workflow. In this case, we've got a static part of the template, so /contacts, and then a dynamic part, the ID part that's in curly braces, and that ID also becomes a field in the return parameters over here, so that I'm able to take that ID and then map it to a subsequent step in the workflow. In this example, I'm using that ID to assign a parameter to a SQL statement so that we pull that desired contact ID. And then once we've pulled the data that we want, and we want to inject that into the response and get it back to the caller, we can inject that into the body property. And along with that, we can also set response headers and a status code if we want to customize that behavior. And finally, let's have a look at MCP triggers. So these are a more recent addition to the platform, but we added them to V1 late last year, and this is the V2 version for MCP tools. Here, the main identifier is going to be the tool name. This is the name that is made available to the LLM along with descriptive information, so it knows when this tool should be invoked. And in the case of this particular tool, I have two arguments, or parameters if you will, one for the notes that should be provided for the expense claim, and then second for the expense ID. And again, I'm using those returns from the receive step as inputs into the Sage and TAC node so that I can take the desired action. And then finally, I have the respond node that provides the response back to the caller, which would be the LLM, so it can continue with its actions. Now, in our V1 runtime, Droppoints provided a way to integrate with on-premises data sources. In V2, you can install and register a local Flowgear cluster and then select it in a workflow so that the entire workflow runs in your own network or on-premises. As the name implies, local clusters can contain multiple nodes, enabling high availability for these workflows. So before we get into this, let me just run our local cluster here. All right, over to you.
All right, thanks, Dan. So for this, we're just quickly going to go to our settings, to our cluster page. So just navigate to settings, go down to clusters. So what we see here is here at the top, we have our cloud cluster hosts. So these are all our hosts running in cloud that your workflow defaults to run on. We also have some metrics like our resource utilization, workflow activations, as well as platform log entries and errors. You can also drill into this to get more details about which processes are running on each of the hosts. Then down here at the bottom, we have our local cluster. So this is what Daniel mentioned now. So you also said you can have multiple nodes running here. And to register new local clusters, as easy as coming here, entering a name and description and hitting save. You'll also just upload a certificate then to prove its identity. And then once you've done that, you're ready to go and run a workflow on your local cluster. So just going to go back to our workflow screen. Going to go to our pre-built workflow. Going to go in here. So this workflow has basically is reading source from a file, parsing it into a CSV, creating a CSV, then from that concatenating the names into a full name and writing that file back onto the local machine. So what we can do here at the top, we'll see there's a drop down here. So you have your list of local clusters as well as the cloud cluster. So in our purpose, we want to ensure that it runs on our local cluster. So it runs on the machine that we've just specified. We're just going to hit run. So as we can see, the logs are starting up. And now we've been able to read from this local machine, parse it, and read it, write it right back. So each workflow runs on either the cloud cluster or a local cluster. It's up to you. And here's what's cool. When a workflow calls another workflow, execution can jump from cloud to local or back again. So whatever makes sense for what you are doing.
So we've seen how the new runtime provides a completely new design experience paired with AI that amplifies your productivity. We've also looked at how the new engine is designed to work with large amounts of data without trading off performance. And we're excited to bring this to you, and we'll be rolling out a preview release in the coming weeks. To get up-to-date information about the release, as well as answers to questions about V1 and V2 runtimes, search V2 Runtime at help.flowgear.net. Thanks for joining us, and we'll see you next time.